Action.
Good
Morning.
morning, ladies of calculus. Welcome to room 15, where?
Learning
Never ends. Even if Kenzie's not here, well, I hope she's coming back, so I hope she's feeling, is she feeling better?
No.
No. She's pretty wiped out. Here's what we have here. I want you to go to this example 5, and I don't want you to do all of it. The oil tank spills oil that spreads a circular pattern whose radius increases at 50 feet per minute. How fast are both circumference and area? I want to go ahead and, I don't want you to do circumference. So the area, how fast are the area, or how fast is the area? It changes. How fast is the area of the spill increasing when the radius of the spill is, we'll say just 20 feet. Okay, how fast is the radius of the spill?
How fast?
Is the area of the spill increasing? How fast is the area of the spill increasing when the radius of the spill is 20 feet? So I want you to do that one. So, okay, are you guys going to be gone on Thursday?
Yes, we are.
Okay. Where are you going?
Woodward.
Okay.
Principals, the school won't let us get out of town because we perform at 1:30. Okay, anybody have an answer for this yet? Getting there.
How much more time do you need for this one?
5 minutes.
I'll give you 3 minutes. Más. 3 minutos más.
Why are you speaking Spanish?
Why am I speaking Spanish? Just, how did you know I was speaking Spanish?
Because I know some Spanish, I just don't.
Okay, so you knew enough to know that I was speaking Spanish. See, that's good. I'm a believer in cross-curriculum work.
We have a play of basketball called Uno Mas. One more.
Un más?
One more.
Yeah. No, I'm a believer in cross-curriculum education. Why do you think I'm a believer in that?
I don't know.
Because I like it when the subjects I like to see that subjects are related. That's why when you asked me about physics, remember last year you were asking me about vectors and all that? See, I like that because that's an application. And I like when, like today in Algebra 2, we were talking about, we were doing systems of equations, and so we were translating the word problems into equations. And to do that, we had the word is an equal sign. So I just like that. And my point of view is, I think mathematics is important in this world today, but overall, it's a small piece of the overall body of knowledge. Would you agree with that? It's an important piece, but it's just a piece of it, right? But it's all fitting in together. Okay, so we have a circle that radius, so this radius here, it's increasing, and we know at 20 feet, so we know in this direction, dr dt is going to be equal to 50 feet per minute. And then, so we have find, we want dA dt when r is equal to 20 feet, given, you're given dr dt is equal to 50 feet per minute. And our equation is going to be, what's our equation going to be?
Pi r squared.
Area equals pi r squared. So now let's take the derivative of this. What's our derivative of this? dA dt equals
2 pi.
Pi dr dt. So now we can plug in. Where do we plug in? 50, right?
I thought it was 50. Regular r is going to be on 50.
Oh, R, okay. Thanks for reminding me of that. Good job. Now we can plug in, right? So we plug in 2 pi, and that's going to be 20, 50. So that's going to be 1,000, is it? 1,000 times, so that's going to be 2,000 pi, right? It's going to be feet squared per minute. Is that right?
Yep.
So who got that as an answer? Okay, so, okay. No, good. All right, what I want you to do is, we're going to go to look at a different problem. I'm going to look for the right kind of one. Okay, sphere, changing, right circular cone, rectangular well. Okay, let's do this one right here. Find the, I want you to do part A. Let's not worry about the angle of elevation, although that could be done. So I want you to go to this problem 6A, ladder, a ladder problem, the lower end of the ladder being pulled away from the wall at the rate of 2 feet per second.
Mr. G.
I can't find it.
You can't?
Oh, I found it.
Mr. G, you want to see my project?
No, I didn't.
Yeah, I do now. I'll see it, but I gotta be careful here, because in 7th period class the other day, you know what happened? We had Lily and Maddie were talking about palm dresses, and they mentioned that we're talking about butt cracks. They don't want to get butt cracks.
Yeah, he just put that in the video.
Well, that's okay. Never mind that. Anyway, we did that. That was actually in the title of the video. That's very, well, that's a nice dress. And see, when you turn it on the back, you don't see any. Right?
Yeah.
So that's what they were talking about.
Oh, okay.
So we made the title, we made that the title of the video for the class that day.
Wow.
This was.
Right here. Yeah, it's not.
What day is the prom gonna be?
March 5th.
March 5th? Okay. Do you know where it's gonna be yet?
The harbor in, where was it?
You did not call it that. Wait, calculus?
No, it was
Pre-calc?
No, it's Algebra 2 honors.
Algebra 2?
Algebra 2 honors, yeah.
I don't know exactly where it's at.
Okay.
Oh, it's,
Harbor or something.
what's it called? You didn't put that on there?
I did?
No.
Let me show you. So here it is.
I went to your page and it wasn't.
Your channel. Videos. Here it is. See it?
Oh,
58 views. There it is.
58 views. Wow.
That's a popular one.
Probably.
Yeah, they liked it. It was like a clickbait thing. Then another one we had the other day. We had orphan discussion. That was another one we
We'll
had.
have a lot of discussion, but
Where's the orphan? Yeah, orphan discussion. We had that too. So anyway,
yeah, you don't put our discussions on there.
no, our discussions have been pretty tame overall, and
That you know of.
that I know, well, that I heard. But one time he told me not to post something when we talked about another volleyball player, and I didn't. Okay, so we're going to find how fast the top of the ladder.
Are you serious?
So we have this 12-foot ladder here. So here's the ladder, 12 feet, and it says the ladder's being pulled away. So in this direction, it's going to be, so we have x, we have dx dt is equal to 2 feet per second. And then we want to find out how fast the top of the ladder. So question mark, dy dt. And so we're going to find dy dt, and we know dy dt should be a negative number, right? Yeah. So when y equals 6 feet, and we're given dx dt is equal to 2 feet per second. And our equation is going to be what? What's our equation going to be?
X squared plus y squared plus 12 squared.
It's 12 squared. And what's our derivative of that? 2x dx dt plus 2y dy dt equals,
140.
no, derivative of that,
0.
0. And so we're going to go ahead, we can plug in right now if we want to, which we're going to do. So we have 2, well actually, we know this is 6. 6 feet above the ground. What's this thing right here? Well, it's going to be square root of 144 minus 36. So that's going to be 108, is that right?
Yes.
Square root of 108. So we have 2 square root of 108 dx dt, which is 2, plus 2y dy dt equals 0. So that's going to be 12. So dy dt is going to be equal to negative 2. That's going to be times 2, right? So that's going to be negative 4. 2 times 2, negative 4, square root of 108 over 12, right? So for that, we're going to get negative 108 over 3. That's going to be feet per second. I hope that's right. Karina, tell me that's right. Is that right? She thinks so. Okay. I like that. Anybody else get that? You got it? Emily got it. Okay. Good. So a little cleaning up stuff, and we didn't get a nice clean triangle like the other ones we did, but that shouldn't be that hard. Okay. Now, Emma was asking me what we're going to be doing tomorrow. Are you going to be gone just one day?
Yep.
One day tomorrow, okay. I want to do another type of problem too for related rates, but I want to get started on this today. So let's go right to the next note card, which is 37. Antiderivatives. So here we have a function f of x, antiderivative of function if f prime of x equals f of x for all x in the domain. The process of finding an antiderivative is called antidifferentiation. So basically, and what it does is it gives us all this stuff right here, and I'll tell you what it relates to. You remember we had f prime and f double prime. Remember that? Okay. The thing you need to remember is in differentiation we're going in this direction.
Antidifferentiation going on the other way.
Yes, exactly. So antidifferentiation is going like this. And so we're going to learn how to do this direction. And then what it is, they give just different nomenclature for this. And so if f is any function such that capital F prime of x equals f of x, then, so what this amounts to is what we had, several of you got our calculus t-shirt, and I wonder if I have it here. No, I think I have it at home. Remember the chicken and the egg?
Yeah, we have those.
Yeah, the chicken and the egg. So the chicken and the egg situation is, it says, I forget exactly how it says, but they are opposite directions of each other, is what they are. And so we're going to go ahead and work on exercises that quantify this. And so if you have a function such that big f prime of x equals little f of x, then the integral of f of x dx is big F of x plus c. And it's called the general solution, and it's called, when you put a plus c, and if you recall back to the calculus song, there's something that we talk about that, the constant, should never forget to add a c, whatever. So we're going to be working on those types of problems. So basically it's getting around. I told you about snow cone Santa Claus, didn't I?
We sounded about it a little bit.
That's in there. So snow cone Santa Claus has to do with sine and cosine. And so if you take the derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, and derivative of negative cosine is sine. So that's what we do. But for integration, we go the other direction. Integral of sine is negative cosine. Integral of negative cosine is negative sine. Integral of negative sine is cosine. And integral of cosine is sine. And so what this does, it helps keep track of sign changes, because that's the main thing that happens when you integrate between sine and cosine. So, right here, we have this one, a state 3 function, big F of 1, big F of 2, F of 3, whose derivatives are f of x equals 3x squared. So find two functions that if you take, basically what you're doing is, if you take the integral of this, what is this going to be? The derivative of what equals that?
What's the derivative of?
So you're asked to find it, so it's an antiderivative. So the derivative of what thing will be that? Derivative, so
Yeah. X cubed.
so x cubed would be 1, right? So we'll say that's one function, f1 equals x cubed, right? So that's an antiderivative, so that's one of them. We need to have 3 of them. Okay, so let's have is there another one you can think of? F2 is what? This is definitely a correct answer, because if we take the derivative of,
Can't you just add like a number on the end of it as long as it doesn't have a variable?
yeah, okay, I'm going to do that. Go ahead. What's one of those going to be?
X cubed plus 6.
Okay, so there's another one. Okay, can somebody else give me another one?
Q plus 1.
So there we have. And I'm glad, because what happens is, Emma caught the trick, okay? So that was really an exercise. And so that's why we have to have the C. Well, we call it indefinite integral. So that's really going to be it. We're going to be working on things like that. And that would be pretty much it for today. And we'll get ready for class tomorrow.